How can we structure our research in a way that can test the plausibility of one explanation versus another? How can we tell if a fact represents confirming or disconfirming evidence for an explanation? Earlier, we published a story map, datasets, and a series of GeoDa demos on the case of Dr. John Snow and the cholera epidemic in the 19th century in order to introduce his way of thinking and replicate parts of the analyses that he ran with modern spatial analytic tools. Now, we return to this case to take a closer look at the quasi-experimental research designs that were used during this time to test if factors like water or air were the most important modes of transmission of cholera. During the summer of 1849, a row of 17 houses suffered an unusual cholera outbreak in Albion Terrace, South London, because it left the surrounding houses unharmed. So why did many people in Albion Terrace die while their neighbors survived? To answer this, Snow drew lines of demarcation between observations in order to isolate the difference between them. On the one hand, those who lived in the 17-house row and were affected by cholera, and on the other hand, those who did not live there and did not get sick. He was informed that flooding during 2 severe rainstorms burst a brick drain conveying wastewater into Albion Terrace, and he proposed that dejections from one cholera patient had contaminated the terrace's drinking water supply because of a plan that sequentially filled water tanks behind each house. This was compatible with the expectations of the waterborne theory, but even more important is that this was unique to the group that had become affected by the disease, which explained why the people who suffered from cholera came from there and not from the group of surrounding houses. Another case is that of the Soho outbreak during the summer of 1854. Local residents thought that cholera was spreading due to morbid gases emanating from a 17th century Great Plague pest field as new sewers were being built. And since miasma was considered the most likely explanation for the transmission of cholera at the time, Edmund Cooper, an engineer with the Sewer Commission, created a map to see if deaths occurred more frequently near untrapped sewer grates and ventilation shafts, but the map showed no relationship between them and deaths. Snow was convinced that the cause of the Soho cholera outbreak was waterborne, and he fingered the Broad Street pump as the likely cause. Thus, he commissioned 2 spot maps to depict his hypotheses that deaths increased as the distance to that pump decreased. In this case, non-deaths were just as important as actual deaths for testing the theory, and he found out that the 2 anomalies in terms of deaths were a brewery and a workhouse where the source of drinking water was not the pump, but wells and private pipelines. Snow also learned of 2 women who died after being delivered drinking water from the Broad Street pump, despite living miles away from it. All of this evidence aligned with his waterborne theory. Finally, the South London natural experiment was the most comprehensive of the 3 examples because it allowed Snow to apply his demarcation logic at the subdistrict level. Between 1849 and 1854, years in which 2 major cholera outbreaks took place in South London, new legislation required any private water company that drew water from the River Thames to move its supply source upstream, beyond the tidal reach carrying London sewage, by 1855. The Lambeth Company, one of the 2 major water suppliers in South London, had made the switch by 1854 when cholera returned, but Southwark and Vauxhall, its main competitor, had not. Some of the sub-districts were served by both water companies. Because of that, Snow ended up with many groups to compare. The sub-districts served by either Southwark and Vauxhall or Lambeth, or both, first in 1849 and then in 1854. Snow pointed out that there were no discernible differences in class elevation, population density, and air quality in the intermixed areas that the 2 water suppliers served. From what we know now, this made these alternative explanations to the waterborne theory of cholera less plausible. Once again, the results of his analysis failed to reject the expectations of his theory. Indeed, Lambeth's supply in 1854 had many fewer deaths than during the 1849 epidemic, whereas most sub-districts only served by Southwark and Vauxhall had more. Since the only major change that had occurred in that time frame had been the change of Lambeth's water source, this was strong evidence that the waterborne theory of cholera was more plausible. Ironically, though, this was also compatible with a variation of the miasma theory that stated that impure water could be a predisposing cause of cholera, but not the ultimate one, which prevented Snow from convincing others to drop the airborne theory altogether. From our perspective today, the way in which Snow was able to build a compelling case for his waterborne theory of cholera was based on demarcation, which allowed him to investigate deaths from cholera among people who differed in one crucial element that could then be tested as the explanation for the puzzle. If you would like, you can consult another story map by the Center for Spatial Data Science on how the demarcation logic is also used in fiction by Sherlock Holmes when solving mysteries. The link is below. Let us know if you have any feedback.